Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, nice to see you all. My name is Setiawan. I'm from Research Center for Informatics, National Research and Innovation Agency, Republic of Indonesia. For this precious moment, I would like to present my paper entitled IndoAlgae, the database of Indonesian native strains of potential marine algae. The outline of the discussion is as follows. First, we will talk about the background that motivated this research. Second, we will look at other works related to online marine algae databases. Third, we will discuss the methods used in the study. Fourth, we will discuss the results obtained from the study. Fifth, we will talk about the challenges we face for our future works. And sixth, we will draw conclusions from our research. Okay, first, we will talk about the background that motivated our research. One of the marine resources that has an important ecological and economic role is algae, both microalgae and macroalgae. Algae has enormous potential, but its utilization is still minimal. Of the 10,000 species of microalgae identified in the world, only 5 to 6 genera were utilized for mass production of biomass. This shows that the potential of microalgae to be utilized by humans is still abundant. In addition to being used as an alternative food source, microalgae are also used for medicine, cosmetics, and alternative renewable energy. Indonesia is the second largest aquatic algae producing country in the world, according to FAO data in 2018. In order to innovate and diversify the use of micro and macroalgae, information related to species, distribution, and potential utilization is very much needed. However, Indonesia does not yet have a data center and information on this wealth of resources. In the internet era as it is today, information technology has a significant influence in conveying messages to the wider community. On the other hand, data collection in the form of a database that is connected to the internet so that it can be accessed by anyone and from anywhere has become very popular and needed by the community. For this reason, we conducted activities to compile a database of potential marine micro and macroalgae native to Indonesia, or MALSAI, which was then published on an open access website. Related works. Researches related to building an online algae database have been conducted by several previous researchers. The oldest one was done by Geary et al. By building AlgaeBase in 1996. This effort was then followed by similar activity carried out by Silva and Mu from the University of Berkeley by building the Nominum Algarum Index in 1999 and Algaterra, which was built by Jen and Kasper in 2007. Subsequent studies tried to build an online algae database at the country level. It was done by Davis and Pesanti in 2011 by building a database of natural compounds from marine algae, especially from seaweed, namely Seaweed Metabolite Database. Their compatriots, namely Bushan et al., established DBINT Algae in 2016, a database that provides information about the geographical distribution, morphological characteristics, and most importantly, sequence data of marine algae collected from different coasts of India. The methodology used in this study was following the stages depicted in this figure. The first step is data collection. Data collection was carried out on primary and secondary data. The target was to collect 100 species data of marine micro and macroalgae in a year. Primary data collection was conducted by gathering micro and macroalgae specimens in potential locations with high algal diversity, such as in North Sulawesi and West Nusa Tenggara. Secondary data was collected through literature review and discussion among depositors and algae experts to complete the algae attributes data. The attributes that I tried to be completed other than photos are the sampling event, the coordinates of the collection, the name of the species, and the potential it has. The second step is system development. A system was developed to enable contributors to enter potential marine algae data into the database and allow public to browse the data. The target to be achieved at this stage was the operation of the multi-site system that can be accessed via the internet. The next step is data entry process. Data entry mechanism was designed collaboratively so that every contributor can enter data into the system and can change others' data but cannot delete it. Admin conducted data review and intermediation to see the completeness of the data entered and its eligibility to be displayed to the public. The target wanted to achieve at this stage is all collected data are entered into the system. The last step is continuous updating. Efforts to build a database of potential marine algae of Indonesia do not stop here. We want this process to be carried out continuously. We are targeting to enter 100 to 150 data into the system every year, so that by 2024, it is expected that there will be 500 species data in the multi-site database. In the future, we hope that this database can be maintained and developed to support the use of marine micro and macroalgae in various fields. Now we come to the research results. The results that were obtained in this study are as follows. Data collection. Algae data collection through plant field surveys was carried out at 4 locations during the period January to March 2021. This data was then added with survey data conducted individually by contributors in 3 other locations and reference collection owned by a research center for oceanography, Indonesian Institute of Sciences. This table shows a list of survey locations for algae data collection. This table shows that the largest number of specimens collected came from the P2O LIPI reference collection, which was 28 specimens. According to the plan, this research will take specimen samples from 10 locations. However, due to the COVID-19 pandemic, sampling was only possible in 4 locations. The remaining samples required were taken from the contributors' private collections and the P2O LIPI reference collection. This figure shows images of algae samples obtained from the surveys. Requirement analysis. System development begins with a requirement analysis process. At this stage, we analyze the functional and non-functional requirements of the software tailored to the user's needs. Functional requirements contain the functions required by the user that must be available in the system. The functionality provided by the system is represented in a use case diagram as seen in this figure. From this figure, we can see that there are 3 types of users using the system, namely admin, contributor, and public. Contributors have the right to change passwords, manage taxonomy data, manage event data, manage depositor data, manage specimen data, and view users' activity log after logging into the system. Admins have rights like contributors have, with the additional ability to manage administrative region and user data. Public is only allowed to browse and view collection data, such as browse species, specimens, events, depositors, contributors, and view algae distribution map. Design. The next stage is system design. The system design consists of database design and interface design. Database design consists of the design of entities and relationships between entities involved in the system and the designs of table structures. Entity design and relationships between entities involved in the system are described in an entity relationship diagram as illustrated in this figure. Implementation. After the system design has been completed, the next stage is to implement the design into a series of technical work to realize the expected software. At this stage, the design was implemented into a web-based application software. The database design was implemented using MySQL, and the web application was developed using PHP scripts. The application was divided into two parts, front-end and back-end. Front-end is the part of the interface that is seen by public users, while back-end is the part of the interface that is seen by admin users and contributors. Unlike the front-end section, to access the back-end section, the user must first log in to the system. Deployment. The final stage of building the multi system is to deploy it. The system that had been developed and tested for functionality was hosted on a virtual private server running Linux operating system. The data was stored on the MariaDB 10.3 database server, and the web application was published on the Lightspeed web server running PHP 7.4. The multi-web application can be accessed at https://www.indoalgae.org. Data entry. Data entry activities were carried out by contributors from January to March 2021. The results of the data entry process are presented in this table. The number of species entered into the system is the target number of species to be achieved. However, in reality, the number of specimens collected was not surpassed the planned target due to the ongoing COVID-19 pandemic. In the following years, the number of data entries will be raised to reach the target of 500 species by 2024. Future works. The development of a database of potential algae that can be used as a reference for the community certainly cannot be done in a short time, but requires continuous efforts. In addition to completion of the data, in the future, this potential marine algae information system will be developed into mobile devices to provide a form of access to other types of devices and attract more users. Innovation will also be carried out by providing facilities for users to be able to identify types of potential algae based on their characteristics. Conclusion. The forerunner of Indonesia's potential marine algae database has been successfully built. At the initial stage, 98 data of algae species with 60 specimens from 9 events were collected. A web-based information system called IndoAlgae has been developed to provide facilities for contributors to enter data into the system and for the public to browse the data. The IndoAlgae website is able to provide information to the public about types of marine micro and macroalgae, descriptions, morphological characteristics, compound content, and their potential utilization. Okay, that's all I can deliver for this moment. Any comment or suggestion to improve the quality of our study is highly appreciated. Thanks for your attention. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh.